Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. You know, I want to start this video with a shout out to the gentleman that I will credit the success of my channel to, and I'm talking about Chuck Bomarito at Outside Screwball. About 2 years ago, the guy did a video completely unsolicited that he called my favorite pie, and that really lit the fuse to my channel and sent me a tremendous amount of interest and followers and subscribers, and Chuck, I will be forever grateful for that. So thank you very much. This is his sticker up here. If you haven't checked out Chuck's channel, go over and check it out. He's got a great personality and his material is always entertaining and informative. So thanks, Chuck. Today's topic is going to be form tools. I have a lot of people that have seen some of the Canon videos and some of the other lathe videos and said, well, what about form tools? How do you grind them? How do they work? What are they? What are the restrictions? Blah, blah, blah. Well, the form tool is any tool that's going to give you a feature on your part that's outside the linear capabilities of your part. It's not going to be a turn diameter. It's not going to be a face. Basically, that's where it stops, because an undercut tool could be considered a form tool. A corner rounding tool could be a form tool. Any turning tool that you use that you put a specific radius on could be considered a form tool. So when you get to the back of a Canon, it's got this taper and this radial undercut and this ball configuration, and a lot of people would look at that and go, not in my shop. Well, if you break it down into segments or quads or details or features, it doesn't have to be as scary as it may initially appear. So I'm going to draw it on the board, and I'm going to draw up a couple of different ways that we could possibly do that, and then I'm going to go out and grind the tool, and I'm going to do it. So the back of this Canon, we're going to start off with a marker that actually works. And boy, I got a lot of them. Let's try that again. There is nothing wrong with your TV. Do not adjust the picture. There we go. Okay, this is the bar stock hanging out of the chuck. Operator standing here, we're looking down at it. This is the final undercut on the part, or the final relief on the taper. So this would be a hard line. Yes, it would. And we're going to go angle, angle, radius. Here comes the ball. Now, based on the dimensional requirements of your print, of your part, of the tolerances on the drawing, of whatever the feature is that you're making, will determine how you create that tool. If it's very precision, chances are you're going to need somebody with a surface grinder and a precision wheel dresser and a comparator and an overlay to make sure that that tool is going to cut the way you think it is. On something like this particular undercut here could be done a couple of different ways. I'm going to grab a different color so you can see what I'm talking about. Okay, let's look at it feature by feature. You have a round, you have center line, of course, you have an angle, and you have a radius. What do you have for tangents? You have a tangent here. I'm going to wipe it out with my fingers so you can see it. That's where one radius comes around and meets the other radius. And as far as tangent radiuses are concerned, the one good thing to know is that the center lines of those features will always be in line with the tangent point. So as far as construction goes, if you ever need to start fishing around with dimensions and figuring out what's going where, keep that in mind. The tangent point of any two radiuses will always be the third point in line with the centers of those radiuses. It's a good thing to know. This back angle right here, how hard is that to do? Do it two different ways. Do it with a tool that has the round already on it. Then use the compound to walk that tool in. It makes the cut. When it gets to the depth, you can see what has happened at the bottom. You've tracked your angle, tracked your face, and the profile of the tool at rest gives you this particular angle. Not that hard. Now this is where sequence comes in, so pay attention to this. We now have part that looks like this. Let's just say you've created this. This will probably start hitting the inside of the tool, so be careful how your tool is ground. Just be aware of that. You now have to create this particular geometry. This particular geometry can be done with a conventional corner rounder. No problem whatsoever. Little dots are the relief. And then this guy right here, because this will be a sharp corner at that point, you can do that with a 45-degree tool, and you can file here, or you can take the time to create a tool that does this. You can also do that radius with this tool. Just turn it upside down. You may have to grind a tip on it so it doesn't hit anything, but there it is here now. It's inverted. Inverted this way. Might be a little bit of timing involved. And the other thought, when you start using form tools do increase the surface contact of your tool, because naturally you're doing a sweeping geometry or a radial geometry with the entire face of the tool. So sequence on a part like this would be rather important. Which tool do you use first? Well, just by looking at this, I would say this particular cross section right here, this distance, this dimension is a whole lot less than this dimension right here, lengthwise. So if this was finished before this, chances are when this surface contact exceeds this cross section, the chances of that little ball bearing becoming a projectile is pretty good. So ideally, do the nose first, then you can do some degree of relief, this one, and then blend it. Work towards the smallest feature first. You're going to be glad that you did. It's like turning a wine glass or a champagne glass in a lathe. The last thing that you would want to do is turn the flute before you did the contour of the shape or the inside of it, because you have absolutely no support. So keep your support material on your part until the very last, if you can. All right, let's go out to the lathe. Well, actually, one more detail on this before we go out and grind up the tool. I'm going to talk to you about grinding wheels too, because I just recently watched a video where a guy was doing some grinding, and you got to be careful with the wheel selection, because you can do damage to the wheel, load it up, clog it up, heat up the next part in line, totally nullify the effective grit nature, the coarse nature of the wheel that you're using. So wheel selection is important as well. If you grind a form tool, whether you're grinding it by hand or whether you're grinding it on a surface grinder, and you take that form tool over to your part and you hit the part, and then you put the part on a comparator or put a radius gauge on it, and it doesn't look like the tool, and you got to go, well, how come? Because the tool was absolutely perfect. Well, this is how come. And this is just for visual reference. I think that's dark enough, straight enough, and probably horizontal enough to be effective. Here's your problem. Against my shirt, this is a 90-degree corner. This is a 45-degree triangle, so to speak. Perfect example. I'm going to trace the outside of this when we sit on this line. Now, if the top of your tool was flat, no relief whatsoever on the top of the tool, none, it's flat. And the feature that you're grinding in is absolutely perpendicular to the machine, square to all the surfaces on the machine, or square to all the surfaces on the tool bit, you're going to have a form tool that gives you a perfect corner. It may rub because there's no relief, but you're going to have the corner. Well, as soon as you set that tool up in your machine and you put the 5-degree and the 5-degree and you relieve the top, this is what happens. Watch the angle. And I hope that's right in line with the camera, because it'll be sad if it isn't. As you start to put relief on that tool, this is what's happening to the geometry of what you're grinding into that tool. Now, I hope that you can see on camera, this is really drastic, but I hope that you can see it, that the original angle dressed on that wheel, once you start to move your tool, it changes. until realistically you want to go all the way down with the tool, it turns into a straight line. So as you add relief or rake to the angle that you put on that tool, the angle increases, because you can see that. I hope you can see that. All right, that's an angle. With the radius, all kinds of weird stuff happens with the radius. You start to get a lead in, a lead out, and the radius itself starts to go flat. Same way as the angle just did. This is about a 3-inch radius, and over 90 degrees, 45 degrees in, 45 degrees out. This is really slippery. Okay, now as you add the rake to that tool as it stands up in the setup and you're grinding it, well, check it out. The radius starts to flatten out, the lead starts getting greater. It's no longer 90 degrees, 45 in, 45 out. On the tool it is, but not on the part. So as that angle lays down, everything changes. I hope that came through, and I'll find out momentarily. All right, let's go out, take a look at the grinding wheels on my grinder, grind up a quick tool, and start with the end of the cannon in the lathe. Now this cannon project is not just a, hey, take a look at this, I'm making a cannon. I hope that you're getting out of it the sequential thought that's going into how the tools are coordinated, how the machine is set up. That's the whole idea. Anyway, okay, back to the grinder. Let's take a look at the wheels. For today's demonstration on grinding that form tool, I am going to do it on a Baldor grinder. I'm not going to do it on a surface grinder with a fancy wheel dresser. I'm going to do it on the good old pedestal grinder that probably 100% of the guys watching this video have standing in the corner of their shop. May not be a Baldor, but I'll bet you have one of these in your shop. Okay, when you walk up to your grinder for the first time, unless it's a shop grinder, take a look at your wheels. If there's any kind of silver reflectivity in the wheel, you can see a couple of spots on this one. This is my roughing wheel, so I really abuse this one. And this is in dire need of being dressed because it's starting to get clogged. This is my finishing wheel. Checking the wheel like this is a really good idea. Look for chips, look for giant wads of soft metal that the engineer came down from the office and slammed the aluminum piece of his boat in there to grind a nub off or something. Got it all clogged up and went back upstairs and didn't bother to tell anybody. Look for chips in the sides, just anything that doesn't look right. These things have some major league explosive potential, and if they've been abused or damaged, it's a really good idea to throw them out. Now here's a little treat for you that you may or may not have ever considered. This is my little buffer station. This is a hard Scotch-Brite wheel for taking burrs off. Works well for steel, works well for aluminum. And this is my Scotch-Brite wheel to get the scratches out. If you watched my AR series, then you saw this guy in operation. Flap sanders. Everybody has seen these flap sanders at the local home center. I can tell you they work really good until you start to wear grooves and channels in them and you want to flatten them out. So when you decide to flatten it out, say, all right, I'm going to press something up against it. But guess what? This is an abrasive, and whatever you press up against it, it's just going to start to cut it down. Well, the secret to truing up a flap sander is to reverse it this way. All right. Now the leading edge of the wheel, as it comes around, is the cloth side. So whatever you press up against it, it's just going to start to wear the cloth out, and then by the time it gets through the face of the cloth where the abrasive is, it's going to be nice and flat like that. So that's how you dress a flap sander wheel. Turn it around, mount it, fire it up, press something against it. And believe it or not, I dress these wheels with a house brick because they're readily available. Everybody's got a brick laying around. Just press it up against it, walk it back and forth, and away you go. Flat. All right. Back to the grinder. In order to clean a wheel like this, there are several different options. There's several different ways you can do it. And before I grind the form tools, I'm going to make sure that my gaps are correct, my angles are correct, and that the wheels are clean. This is the preferred method for dressing a grinding wheel. Got a bunch of little rollers in here that all spin in different directions, or they're capable of spinning in different directions. press it up against your wheel, and I will tripod mount this, and I'll do it so you can see how noisy and dusty and nasty it is. And after you're done reducing the grit content in the face of your wheel, your gap is going to be big. You don't want anything that you can get your finger jammed down in, or what I call a mouse trap. You got a nice big gap, you're grinding away on your tool, and your tool tries to dive into the gap. Well, guess where your finger's going? Your finger's going between the tool and the wheel. So this is an important gap. On my grinders, I keep my roughing wheel at an extreme angle so it removes a bunch of the material below the tool profile that I want to ultimately cut. That way when I get over to the finish wheel and it's at a greater angle, the tip of the tool hits first and it comes around. It's a lot easier to grind the tool. If this is a tool you're going to surface off quite a bit, well then make sure the platforms that you're grinding from are at the same angle, so whatever profile you put on there goes all the way down. Alright, set this thing up on a tripod and make some dust. We are going to use this dresser. Mild pressure. If you have one that has feet on it, make sure those little feet go down, and that'll help you keep the thing from rolling back and forth. Work it back and forth across your wheel. And you'll see it when it gets clean, it gets nice and white. There is actually no good reason to knock the radiuses off the corners of the wheel unless you need to grind something sharp. It is only the, now this thing is still spinning, probably going to spin for 20 minutes, but it's just the front surface that you need to grind. Okay, you can see that the shiny sparkly stuff is gone. The grain of the wheel is open real nice. And that is the optimum condition for a wheel right there. That's beautiful. This one is nice and flat as well. The gap on the finishing wheel is acceptable, and in my opinion the gap on the roughing wheel needs to be adjusted. So let me adjust these. I'll lay the tool out there we're going to cut the end of the cannon barrel with, and we'll get after it. Two other fantastic options for dressing your grinding wheels, whether it's a pedestal grinder or a surface grinder, are these two guys right here. These are substantially cheaper than an actual wheel dresser, but they do the same thing. This is called a dressing stone. They come in square, they come in round, they come ½ inch like this, they come 1 inch, 3 inch, 6 inch, whatever you want, whatever suits your application. These are exceptionally well suited to Dremel tool wheels. If you have a Dremel tool that has a small stone mounted to it and you notice that it jams up and clogs up really quick, well, you put that Dremel tool up against this thing and you run that power stone back and forth across this. It may eat away at it over time. I've had this one, gotta be 30 years, so you can see how much wear it does not show. But this is really good for dressing Dremel type tools and pedestal grinder type tools. Now the good one. This one is called a Norbide stick, and instead of diamonds, this is about the hardest substance known to man. This stuff just does not wear out no matter what. You could press this against the bottom of a 60 grit grinding wheel on a surface grinder and dress that stone all the way down to the hub, and you might experience that little wear right there. This thing is like a piece of glass. So if you want to put a radius on the outside of a wheel or dress a undercut in the face of a wheel so you can side grind, or put some radiuses on your pedestal grinder, which is what I did to do that form tool that you saw me use. I used this guy right here and just gently massage the corners of the wheel so that I could get the radius that I needed for the form tool. Norbide stick, you can find them in the catalog, and if your catalog doesn't specify Norbide, just look up dressing sticks and chances are Norbide will be in there. Alright, if you don't have a dresser in your shop, get one of those or both of those. The wheels have been properly dressed. The areas where you set your tools has been properly adjusted. And if it's the first time you load a new grinding wheel onto your grinder, make sure that you give it a kick with your finger. Don't get pinched, of course. Give it a kick with your finger and make sure the wheel is not running eccentric and it's going to hit the tool rest. Now ideally, when I take this particular tool, I will figure this camera out eventually. What you want to see is you want to see the left side wheel, the roughing wheel, grind away the majority of the material on the bottom of this face, and when you hit it on your finish tool, you're going to want to see a line form across here towards the top. And if all goes well, about 30 seconds from now, that's exactly what we'll have. Give me a second to grind it up and see what happens. As you can see on the roughing operation, this tool has a, let me get for the reflection here. There we go. Oh. There, one continuous surface. Rather aggressive angle. You can see the angle. And it's a nice clean surface. Now when I press it up against the finish side, only the top edge here is going to come to the geometry that I'm looking for. Okay, that is plenty clear to see. Bottom half is the relief from the left side. Top is your finish. I'm going to take this over to the bench and I'm going to lay out the profile on it that I want for the back of the cannon barrel with a Sharpie marker, believe it or not. And I am going to cut to the lines. And then we're going to go over and we're going to cut the end of the barrel with a hand ground tool. See how it looks.